Hi, I am Dr. Saroja, retired professor in chemistry. Today I am going to discuss the various types of solids. What are the different types of solids? There are 4 types of solids. 1. Ionic solids. 2. Network solids or covalent solids. And 3. Metallic solids. And 4th category, molecular solids. Now let's begin with the ionic solids. Ionic solids are made up of positive ions, that is cations, and negative ions, that is anions. In a crystal lattice structure, it has got a definite geometric structure. These are held together by strong electrostatic attractions. Ionic bonds are strong, and the greater the charge on the ions, the stronger the attractive forces. The smaller the ions, the stronger are the attractive forces. Most salts like sodium chloride are solids at room temperature. These are characterized by very high melting points because of the strong electrostatic attractions. They are brittle and they are very poor conductors in solid state because they do not have free-flowing electrons. Let us see the structure of sodium chloride. Sodium chloride lattice structure is a face-centered cubic unit cell, and this is a cube, and this chloride ions, if you take, this face has in the corners 4 chloride ions, and in the center you find 1 chloride ion. So this is a face-centered cubic structure. And if you take sodium plus ions, if you take this face, then there are in the corners, there are sodium plus ions in the 4 corners, and in the center of the face there is a sodium plus ion. So similarly you will find all over the structure a face-centered cubic unit cell. So this is the structure of sodium chloride. Now let's see the second category of solids, network solids. These are also called covalent solids because they have atoms connected in the lattice by covalent bonds. These are formed by networks of chains of atoms or molecules. Intermolecular forces are identical to intramolecular forces. That is, the forces within the molecule are also covalent, and the forces in between molecules are also covalent. A single perfect crystal is a single giant molecule. Network solids are very strong and they are very hard at room temperature. Example, diamond. It's an allotrope of carbon. Quartz is a form of silicon dioxide, silica. Diamond has sp3 hybridized carbon atoms bounded to 4 other carbons in a tetrahedral fashion, tetrahedral array, to create a giant network. Let's see the structure of diamond. Diamond is a covalent solid. Here you find carbon bound to 4 other carbon atoms in a tetrahedral fashion, and these tetrahedrons are also joined by another covalent bond. So intermolecular forces and intramolecular forces are also covalent. That's why diamond is very hard and strong. Let's see the third category of solids, metallic solids. By the very word shows that these are metallic. They contain covalently bound lattice of atomic nuclei in a sea of electrons or a cloud of electrons. At least 1 valence electron per atom is not bound to any one atom and is free to move throughout the lattice. The freely roaming electrons are called conduction electrons. Hence, metals are excellent conductors of electricity and hence are malleable and ductile. They are all solids at room temperature. They vary very widely in strength. Example, iron, copper and aluminium. Let's see one example of a metallic solid, that is sodium. Sodium has in the kernel, it has got the positive nucleus and 1 electron, the 3s1 electron is free floating, and this electron doesn't belong to any of these cations. They are all free floating, and these small ones are electrons and this is the cation, that is of sodium. So these are the metal ions, big ones, and the small ones are the free electrons. Because of the free electrons, it's an excellent conductor of electricity. Let's see the fourth category, molecular solids. Lattice points are molecules in these solids. That's why they are called molecular solids. These are held together by any of the following intermolecular interactions. What are the interactions? 1. Hydrogen bonds, or they can have dipole-dipole forces or London dispersion forces. They are soft, volatile. They are either liquids or gases at room temperature because of these very weak forces. They are solids only when the forces are strong. All the forces are weaker Hence, molecular solids have lower melting points or boiling points than any of the above mentioned 3 types of solids which we discussed. They are all electrical insulators because there are no free flowing electrons. Let's see the structure of ice. Ice is a molecular solid. Repeating units are made up of molecules. This is one water molecule. The yellow ball is H and the red balls are oxygens. And each of these H2O molecules are bound to each other by hydrogen bonds, because this oxygen is electronegative and this hydrogen is electropositive. So these two are bound by hydrogen bond, and these are all molecular, these are all bound by hydrogen bond, and it is a molecular solid. Now let's see another example of a molecular solid, that is iodine, which is a volatile molecular solid. Here, two covalently bonded iodine atoms are in a face-centered cubic lattice, just like sodium chloride. Example, solid F2 and Cl2 and Br2 also have London dispersion forces. What are these covalent forces and London dispersion forces? Van der Waals forces, Van der Waals forces are dispersion forces due to temporary or permanent dipole-dipole forces. These are in between iodine molecules. Temporary dipole-dipole forces, they originate because the electron temporarily gets displaced in the atom to one side and the other side of the atom becomes positive, so it becomes a temporary dipole. So these are Van der Waals forces are temporary dipole forces, and these are there in the solid halogen molecules. Because of these weak forces, they have low melting points. For example, let's see the structure of iodine. It's a face-centered cubic lattice. This is a cube, and in the corners of the cubic lattice are iodine molecules. This is one I atom, this is another I atom covalently bound. And in the center of the face also you will find one iodine molecule here, and top in the center of the face another here, on the right and left and bottom and back side also you will find, in the center of the faces you will find iodine molecules. This is the face-centered cubic structure of iodine. Similarly, solid halogen molecules also have London dispersion forces akin to dipole-dipole forces. So these are all the examples and 4 different types of solids. Thank you so much. Thank you for a patient hearing, and if you like my video, please subscribe. Now in the next video, I will come up with another interesting topic in chemistry. Thank you.